Chapter 4.1 Systems of Linear Equations. Systems of linear equations. System of linear equations consists of two or more linear equations, although for most of our applications we'll be using only two equations in two variables. The solution of a system of linear equations in two variables are a ordered pair that solves both of the linear equations simultaneously. There are three methods that we will investigate: a graphic solution, a substitution method, and an addition or an elimination method. The substitution and the addition or elimination method is an algebraic approach to solving the equations. Graphing the lines. Since a solution of linear equations is a solution common to both equations, it would also be a point common to the graphs of both equations. To find the solution of a system of two linear equations in two variables, graph the equations by any method and see if you can tell where the lines intersect. Example 1. Solve the system of equations by graphing. 2x minus y equals 6 and x plus 3y equals 10. Go to your graph. Graph 2x minus y equals 6. Choose two convenient points, 0, negative 6, and 3, 0. These are the y-intercept and the x-intercept, respectively. Choose a third point, 6, 6, just to make sure that there are no mistakes. Connecting the 3 points with a straight line yields a sketch or a graph of the equation 2x minus y equals 6. Graph x plus 3y equals 10 by the same method. Choose a point, negative 5 and 5, negative 2 and 4, and 1 and 3. Connecting the 3 points with a straight line yields the graph of a second equation. The two lines seem to intersect at the point 4, 2. So therefore the point 4, 2 is a common solution to both equations. That is, 2x minus y equals 6 and x plus 3y equals 10 both pass through the same point 4, 2. Example 1 continued. Although the solution to the system of equations appears to be 4, 2, you should check x equals 4 and y equals 2 by substituting that into both equations and making sure that it produces a true statement for both of them. Example 1 continued. Substituting the point x equals 4 and y equals 2 into the first equation yields a true statement, and substituting the point 4, 2 into the second equation also yields a true equation. Therefore, the point 4, 2 checks, so it is in fact a solution to the system. Example 2. Solve the system of equations by graphing. Go through the same steps of graphing minus x plus 3y equals 6 and 3x minus 9y equals 9. Go to your graph and plot 3 points for each equation. Connect those 3 points with a straight line. In doing the same for both of these, we see that it is not apparent that the two lines actually intersect. That does not mean that they don't intersect, although they do appear to be parallel. Further investigation of this problem, that is the case where the two lines are in fact parallel, which means that they would never intersect, we can take the first equation and transforming that into what we call the slope-intercept form yields y equals 1/3 x plus 2, and transforming the second equation into the slope-intercept form, we get y equals 1/3 x minus 9. We see that the slopes on both of these are in fact positive 1/3, so the lines are parallel by definition. Hence, they will never intersect, and there is no solution to this system. This is referred to as an inconsistent system. There are three possible outcomes when investigating a solution to a system of two equations and two unknowns. That there is in fact one point of intersection. This is a consistent system. That the lines are parallel, in which case there is no solution, and that the lines are coincidental. In fact, they are in fact the same linear equation, in which case that there are an infinite number of solutions. Let's investigate some substitution methods. Substitution method is an algebraic approach to solving an equation, a system of linear equations. The substitution method is called this because you take one equation, solve for one of the variables, and substitute that into the second equation, which will yield one of the two solutions, either x or y. This is actually a double substitution method. Solve the following systems of equations by using a substitution method. This is example 1. 3x minus y equals 6, and negative 4x plus 2y equals negative 8. Solution. Solve the first equation for y. This yields y equals negative 3x plus 6. Take the equation y equals 3x minus 6 and substitute that into the second equation. Substituting this, we have negative 4x plus 2 times the quantity of 3x minus 6 equals negative 8. In other words, we've replaced y in the second equation by what we solved for in the first equation. Distributing and simplifying yields a solution of x equals 2. This gives us half of our solution. A double substitution method is now taking the x equals 2 and substituting that back into the first equation. This yields y equals 0. So therefore the point 2, 0 is a common solution to the system. Solving the system of linear equations by using the substitution method. A summary. Solve one of the equations for one of the variables. Substitute that into the other equation. Simplify and solve for one of the variables. Take this value and substitute it back into the other equation, yielding a second part of the solution. This should give you both x and y coordinates. You can then check this, of course, to make sure that it does in fact solve or produce true statements for both equations. Now the addition or the elimination method. Another method is called addition or elimination. It is called the elimination method because in adding the two equations in standard form, one of the variables is eliminated. Example 1. Solve the following system of equations using the elimination method. 6x minus 3y equals negative 3, and 4x plus 5y equals negative 9. Solution. In order to eliminate one of the variables, we're going to multiply the first equation by 5 and the second equation by 3. The first equation gives us 5 times 6x minus 3y equals 5 times negative 3. That gives us 30x minus 15y equals negative 15. Second equation, we multiply that through by 3. This gives us 3 times the quantity 4x plus 5y equals 3 times negative 9, leaving 12x plus 15y equals negative 27. Example 1 continued. Combine the two resulting equations. 30x minus 15y equals negative 15, and 12x plus 15y equals negative 27. Notice that when we add these two, that the y variable is eliminated from the system. This leaves us with 42x equals negative 42, and dividing by 42 gives us our half of our solution, x equals negative 1. Now substitute that x equals negative 1 back into the other equation, and this gives us 6 times negative 1 minus 3y equals negative 3, or negative 3y equals 3, or y equals negative 1. So this is a second algebraic method to arrive at a common solution to the system, negative 1, negative 1. Solving a system of linear equations by using the elimination method. A summary. Rewrite each of the equations in standard form. If necessary, multiply one or both equations by a number so that one of the variables can be eliminated from the system. Add the equations. Simplify by using algebra. Find the value of one of the variables by solving the equation. Find the second value by substituting the value from step 4 into the other linear equation. Then you should always be in the habit of checking the solution to make sure that it does in fact satisfy the system. Notes. In a similar fashion to what you found in the last section, use the addition method to combine two equations might lead you to results like the following. For instance, if you end up with a statement like 5 equals 5, which of course is a true statement, this indicates that there are infinitely many solutions to the system. Since the two equations represent the same line, or a possibility is that you end up with a statement like 0 equals 6, which of course is never true. This indicates that there are no solutions to the system since the two equations represent parallel lines. Steps in solving problems. Read the problem and understand what is being asked in the problem. Choose a variable to represent the unknown in the problem. Propose a solution and check. Translate the problem into two equations, that is, two linear equations. Solve the system of equations by any method. Interpret the results, make sure that the results make sense, and you should always check your proposed solution into the original system to make sure that it solves both equations. State your conclusion at the end. Let's take a look at an example of one of these. Hilton University Drama Club sold 311 tickets for a play. The student tickets cost 50 cents each, and the non-student tickets cost $1.50 each. If the total receipts for the drama club were $385.50, find out how many tickets of each type were sold. We're going to assign variables here that will make sense in the problem. So we're going to let S equal to the number of student tickets, and we're going to let N equal to the number of non-student tickets. Example 1 continued. Let's translate this into mathematics. The Hilton University Drama Club sold a total of 311 tickets for the play. This means that S plus N is equal to 311. The total receipts for the play were $385.50. This means that 0.5 times S plus 1.5 times n is equal to 385.50. The two equations s plus n equals 311 and 0.5s plus 1.5n equals 385.50 represents a system of linear equations. Example 1 continued. Let's solve the problem. By solving the system using any method, we're going to take s plus n equals 311 and 0.5s plus 1.5n equals 385.5. Since the equations are written in standard form, we will try to use a substitution or an addition method here. Multiply the second equation by -2. This gives us s plus n equals 311. Multiplying through by -2, we have negative s minus 3n equals negative 771. Adding the two equations together eliminates the s, and we have n equals 230. Since n is equal to 230, we can simply subtract that from the 311 to yield the second part of the solution, that is, s is equal to 81. Notice that the 230 plus the 81 must equal to the total of the 311 tickets. Also notice that the s times 50 cents plus the n times 150 must also add up to 385.50. Example 2, baskets. Baskets Incorporated is planning to introduce a new woven basket. The company estimates that $640 worth of new equipment will be needed to manufacture this new type of basket, and it will cost $15 per basket to manufacture. The company also estimates that the revenue from each basket will be $31. Find the break-even point when the cost of manufacturing baskets will equal to the revenue from selling those baskets. Keep in mind what the break-even point means. First of all, we will define the cost of the equipment, cost per basket, and the revenue per basket made in terms of the number of baskets that are made and sold. So we're going to let x equal to the number of baskets manufactured and sold. Note that we were working with only one variable here rather than two variables, which represents another approach to solving this system. Let's translate that. The cost is equal to the cost of equipment plus the cost per basket. So therefore a cost equation will be 640, our fixed cost, plus 15x, which is our variable cost. Revenue is going to be equal to the revenue generated by the sale of each basket times the number of baskets manufactured and sold. Therefore, our revenue equation is going to be equal to 31x. The two equations c of x and r of x represent a system, so we can apply any method that we've talked about so far to solve this system. Since the break-even point is where r of x is equal to c of x, we can simply set the two equations equal to each other, which yields half of our solution, which is x equals 40. If we substitute x equals 40 back into either one of those equations, that will yield both the cost and the revenue at that point. Let's take a look at another example. A restaurant that serves two types of fish dinners. A small dinner sells for $5.99 each, and a large dinner sells for $8.99 each. One day that there were 134 total orders of fish sold, and the total receipts for that day was $1,024.66. How many orders of large fish and small fish were sold on that day? Setting up a system for this in a similar fashion as we did in the previous will give us our solution. The two equations that we can use in this are S plus L equals 134 and 5.99S plus 8.99L equals 1024.66, where S is the variable that we use for the number of small fish dinners and L represents the variable for the number of large fish dinners.